Hi, I'm Brian Kropp, and welcome to Newton Falls Means Business, a brand new program for Newton Falls Television designed to highlight some of the most amazing businesses in our community. Today we're going to be meeting with Jeremy Sewell, the Vice President of Quality Switch right here in town. We're going to be going inside to check out what they're making and what they're doing for our community. Hi, Jeremy. Thanks for meeting with me today.
No
We're
problem.
really excited to learn more about Quality Switch. How long have you guys been here? And you could tell us a little bit more about what you guys are making here.
Sure.
in Newton Falls.
We've been in Newton Falls since 1985. The company's been around since the 50s, but we're always interested in showing off our capabilities and what we can do. So we can start off with a plant tour and show you what we do.
Great. Lead the way.
All right, let's go. So this is the main manufacturing area here.
Okay, great.
Like I said, we moved into this building in 1985, and actually, being from the Newton Falls area, you might not be familiar with it if you're new to the area, but there was a tornado that came through Newton Falls in 1985, and it actually ripped the back half of the building off.
Oh, wow.
So before we moved in, it was like the day before we were signing the papers to buy the building, the tornado came through and ripped the back half of the building off.
Oh,
so
wow.
we had to renegotiate that, but we got settled in, and we've grown quite a bit since 1985, and we made quite a bit of changes to the facility since then. It used to be like a dirty, dingy machine shop in here, and so we've kind of done a lot to clean it up and make it a more clean environment to build high voltage product here.
Excellent. I'm looking forward to seeing some of the examples of what you were talking about as far as the facilities are concerned. So
Yeah.
what do we have here? What can you show me?
So we're going to take a walk down the assembly area, and we'll stop and look at some different types of switches we make. And most of our product is used in the transmission and distribution side of the grid. So it's stuff it's not general public use. It's used by utilities, or typically the end user of the product. And they're installed inside of big power transformers is typically where our product goes. So we can walk through, and we fabricate most of our products, so we'll walk through the assembly area, and then what we'll start with here is some of the more high voltage applications. So these are used in what we would call transmission type applications. So they'd be in the big substations or at transmission areas alongside the interstate and big power transformers. And what you're looking at here is a big three-phase switch. So it's a big long switch application, and this would get installed inside of a big power transformer, so you wouldn't see any of this from the road. You'd see a big gray box that has big high voltage cables coming in and connecting to the transformer, and our switch is connected inside of that.
Interesting.
So as we walk down here a little bit further, you can see some of our other devices. This is just a switch setup of a simple grounding device. So this is also installed inside of a transformer, and these are used in underground transformers. So in metropolitan areas, like if you're walking in New York City and you walk over sidewalk grates when you're walking in the city, there's transformers under there.
Wow.
And these switches are installed in those transformers, so they help. It's a safety device. When a utility worker goes in to service that transformer, they basically use it as a grounding device.
Now, how long would something like this typically take to design and build?
So the design process took multiple years. It took like 5 to 6 years to get it developed. We had to work with the utility to meet all their specifications, and then we had to go to outside labs to get it tested. And actually, we'd take everything to failure. So we blew it up just to see what it could withstand. And,
That's excellent.
But to build it, now that we have the design done, most of our products are 4 to 5 week lead time items. So we can, everything's build to order, and we'll get an order for this switch, and we'll basically, there may be some minor options and features that'll change on it, but from start to finish, when it's out the door, 4 to 5 weeks.
Now, you mentioned testing, that you send these out and you have them tested. Now, I know from what I understand, you have an amazing testing facility.
Yes.
Do you test these kind of products in your own testing facility?
We do now, yes. When this product was developed, we didn't have the capabilities to do a lot of the high voltage testing in-house, so we had to schedule that outside. And it was an expense. It was time consuming, because you had to build prototypes and ship them to the test lab. And if things didn't go right, you had to reschedule and
do it all over again, right?
So we made the investment a couple of years ago to build our own high voltage test lab, and we'll get a look at that a little bit later.
I'm looking forward to seeing that. That sounds really neat. I'm looking forward to checking it out.
So
what else do we have here?
So as we keep walking down the line, this is just a different variation on a grounding switch. It's also a disconnect and a grounding switch. and it's used in the same type of underground applications, but we've actually patented this device. We've got two patents on this. We designed and developed it to meet the new IEEE standard requirements, which is the governing body that governs the standards for where our equipment's used. And we basically sell these to all the other major utilities. New York City has their own specific specification for their underground system, and then the rest of the country has something a little bit different, and that's where these products are used.
That's extremely interesting.
Yeah.
Okay, Jeremy, you've been telling us about how these switches are built, how they're made, how you manufacture them. Can you show me something in action or show me how they work more specifically?
Yeah, we've got a little display here. I can show you how one of these works. This is one of those grounding switches we were just reviewing, and basically I'll show you how to operate this. It's just a manual lever that basically you operate this and it'll ground out the transformer. So the switch is installed inside one of these boxes, and this will be underground when the utility workers are operating on it.
Cool, let's see how this works.
Yeah, typically you wouldn't even see any of this inside. This would be inside an oil-filled chamber, basically, for insulating and cooling purposes. But just for a display, we have this on hand so you can see how this thing works. So basically the switch loads up, and these little moving parts, basically, there's three blocks of them for 3 phases, because it's used in 3-phase power devices. So used on the grid, and this would ground out the transformer and the incoming cable that are connected to it.
What would the purpose of this be? What would this be used for particularly?
So if a utility line worker is underground in one of these vaults working on one of these transformers or a section of the network that this transformer is hooked up into, they would want to ground out that device to make sure it's safe to enter that vault. And so they ground this device so it's everything, they're ensured there's no, in case somebody re-energizes this and turns it on when they're not supposed to, it holds together and doesn't, there's no arc or explosion in the vault while they're down in there working.
Excellent, awesome, good to know.
Yep.
We've looked at a few of the switches that have been pretty much built. You want to show us some things that are kind of in the process, or show us a little bit more
we can keep walking. So basically down the center aisle, we keep a lot of the components for all of the switches, and we try to group them together in the assembly areas where the switches are built, and we'll have common components that are used on each switch that are fabricated and kept in inventory. So while every switch is built to order, we do production runs of some of the component parts. So we'll have a lot of those things available to just grab and kit and then build the final switch assembly. So we can come together, and you're looking at final switch assemblies built on the end of the line here, but we can come together and look at some of the more common components over here that we do inventory.
Let's take a look at these.
So you see a switch, a complete switch put together, and we'll basically have what we call a sub-assembly put together, which helps our turnaround time. Like I mentioned, 4 to 5 weeks for a finished product on there. But we'll inventory a lot of these components, and then we'll build them up into sub-components. So this same part's used on probably 1,000 different switch designs. So we customize every final switch product, but it uses this same common component. So we'll build this up in bulk and be able to have this ready to go so the guy can just kit the part
much more efficient
and have it ready to go, and basically just build a final switch here. So we'll vary the distances between each tap deck, and a lot of times that'll be dependent on how big the transformer is, what the voltage class is on the transformer. So if you have more space between the metal component parts, that's more clearance electrically, so you'll have a higher voltage switch typically the further these are spread out.
Interesting.
And so a lot of these types of switches are used in pad mount transformers or smaller substation units. So the pad mounts are basically the green boxes you'd see out in front of hotels or restaurants.
Oh, okay.
And things like that. And those are the smallest version of where our switches are used. And some of them, there's bigger pad mounts that are used in more housing development areas, or some of those are even starting to be underground now too, and that's where a lot of these switches are used.
So people see these are out every day. These are things that people see every day and don't really even realize that they're there.
Because these are inside of that product. Cool. And they're basically just used for voltage regulation is what they're used for. So somebody wants 120 volts coming out of their light socket or 110 volts coming out of their light socket, and where the power is coming off the grid, the transformer steps that voltage down, and so there's some fluctuation based on the line runs.
Right,
and where
allows it
that's
to regulate
at.
the regulate the flow. Okay, so we've looked at some really big switches. What are some of the smaller things?
So we do have some small switches. We don't typically try to compete in these really small switch applications, but we do have some that are used in pole type applications. So the kind of transformers you see hanging on utility poles out along the street as part of the distribution.
So like all around Newton Falls?
All around Newton Falls,
awesome.
Yeah. And so this particular design is one that's used in a pole top type transformer. It's a single phase unit, so it's only got one switch deck. You looked at some of the other ones where there were three for 3 phases.
Yep.
So this is just a single phase application, and typically we would sell this component to a transformer manufacturer, and they would install it, and they would connect all of their tap leads up to it, and again, it's just used for voltage regulations. Okay. So you typically have a couple percent up, a couple percent down that you could adjust the voltage of the transformer to get different outputs, and these are the smallest switches we make, and it's rated probably 125 amps and maybe 125,000 volts. Basic impulse level is what it's rated. So,
Jeremy, can you show us exactly how this particular device works?
Sure. Basically, there is some assembly required by our customer. They'll install this inside of their transformer, and they'll run tap leads, basically that'll pick different voltages up off of the transformer winding. And what our switch does is bridge those 2 tap leads. So we have a moving copper contact, and then there's a handle assembly that would be operated by the utility line worker on the end of sticking outside of the transformer, and it basically rotates our moving contact. So it would snap between these 2 positions, and basically they could adjust the voltage output of that transformer. So,
is there a particular time when they would do that? What would be an instance where someone would have to do something like that?
So, for example, if there was a transformer used in a housing development, and they ended up starting with 3 houses in that housing development, and they had the transformer installed and set at a certain voltage output, and then they ended up building 4 more houses, there's going to be a little voltage sag there, so they may want to adjust the voltage output of that transformer up a little bit. So what they can do, instead of bringing in a complete new transformer to accommodate that, they basically adjust the taps of that transformer to give them maybe a 5% more output.
This will do that. This allows them to do that.
That's what our switch does.
Awesome.
Yep.
Jeremy, you showed me some really great switches that were pretty much done being produced, manufactured. Now you do all the parts and all the other manufacturing in-house. Can you show me some of that stuff as well?
Sure, yeah, we've got actually several fabrication work cells, and this one right here we can take a look at. We fabricate a lot of the insulating materials, so it comes through in 4x10 sheets, and then we actually put it up on a vacuum table, and we cut, like this is an example, basically we cut this part out of a full 4x10 sheet, and we basically machine all the holes in it, and we cut it into the square, and this fits together into one of our patented grounding switches that we took a look at earlier.
And what's the purpose of this?
So this is basically it's an insulating material. So it's a high pressure laminate, and it's used to mount the electrical contacts on it. So you have to have non-conductive material between the positions of the switch. So that's what this material does. It insulates between our connections on the switch.
Awesome. All right. Jeremy, you showed me some really cool stuff as far as your manufacturing is concerned, but I see some really interesting looking stuff over here. What's this area over here in your shop?
This is actually our test area, what used to be our old high voltage test area. We've actually converted it. We still do some testing in here. We do some testing on some of our switch designs where we put high current through the switch, and we'll actually monitor the temperature of the switch. And so we actually have one set up here. We put temperature probes in on the contacts, and we'll actually use this current transformer, and we can put up to 3,500 amps through a switch application in here continuously, and we'll monitor the temperature rise. And this is actually set up to mock up how it would be used in a transformer. So we actually have the insulating oil that's used inside of one of these transformer boxes.
That looks really cool.
And so yeah, we actually put view windows on it so we can get a good look at everything and see how everything's going on inside of there. And we'll use this same type of tank for some dielectric tests. We don't use this area much anymore for high voltage, partly because we have the new high voltage lab that we're going to take a look at.
So you have a new high voltage lab? Let's go take a look at that, because that sounds really cool too. If it looks anything like this, I think we're in for a treat.
Sure.
Okay, so we just checked out the old testing center, and I know we're getting ready to head into a newer section of the building. Can you tell us a little bit about that?
Sure. Yeah, this part of the building was added on in 2000, and this is the wall that I was talking about during the 1985 tornado that kind of got ripped off. So this is relatively new comparatively to the rest of the building. So you got 20,000 square foot here of fabricating space, and then this is the additional 10,000 square foot we added on in 2000 for shipping, receiving, raw material, parts storage. We added a 5-ton crane, so we have crane capacity here to load and unload a lot of our raw materials. We used to basically build wood crates to ship a lot of our switches in. Like, as you saw, a lot of those are customized and everyone's built to order, so they're a lot different, but we've switched a lot more to cardboard. So we inventory a lot of different sizes and shapes of cardboard. It's more efficient and cost effective to pack.
Makes sense.
And we'll basically palletize a lot of our product. And so this is where all that is done. And also the raw material storage is done over here, and we have some basic metal cutting materials, and we've segregated the two parts of the warehouse where we only do non-metallic cutting and wood cutting over here, and we'll have separate saws and grinders because you don't want to intermix metal cutting with a lot of the insulating materials. So we have all that segregated, and we do have a small welding area in the back. We do a lot of welding and brazing in the back, and a small little paint booth. Iron worker to do some bending and shearing of material. So we got a little bit of everything in here.
You guys really do it all here.
Yeah, a lot of copper and a lot of brass, but we do aluminum and steel too. There's a lot of components used in the switch that are structural. So
it's amazing. You guys are able to do all this and have, with the engineering and everything and the ability to manufacture all this stuff and do it all in-house. It's really impressive.
Yeah, we like to have more control too. It helps with our quality. Like, we don't sell ourselves as the low-cost supplier. We focus more on quality and delivery. So we're able to turn stuff around by having more control over it, and it gives us more control over quality as well.
Oh, that's great. Fantastic. Well, let's go check out this new testing center, new testing facility you guys have built.
Sure. We got to walk outside across to the other warehouse building here.
All right, great. All right, Jeremy, we've checked out the inside of the main facility. Now we're going to go check out your new testing facility. What can you tell me about it?
This was, we broke ground in 2015, and it was completed about April of 2016, dedicated to just high voltage testing for research and development. And so we participate in a lot of industry standards, and we knew that we were going to have to upgrade our testing capabilities to keep up with those new standards and new technologies as we wanted to develop product for it.
Well, I'm interested to see what's going on inside here.
Let's
so
go take a look.
Me inside.
So here we go into the high bay here.
Oh, wow. Look at this place. This is amazing. Tell me a little bit about some of this stuff. This looks like something out of a science experiment.
Yeah, well, it kind of is. That's kind of what we do with it. We've got 50 feet under the roof here, and most of that clearance is for electrical clearance to the equipment. So we have two pretty high voltage pieces of equipment in here that can do a couple different types of tests for us. And one of them is to actually simulate lightning strikes, and we can simulate lightning strikes up to 1.2 million volts. So that's kind of why we need all the extra clearance around the equipment, because you don't want it blowing up the building.
Can we see lightning in here today?
We can do a demo, and we can actually create a lightning strike. A couple of the pieces of equipment we had, the contractor that actually built our steel building on the addition onto the manufacturing facility is the one that constructed this building, and I think he got a little more than he bargained for when he was doing the build work here. Everything you can't see under the ground, all the rebars welded together. We had to put like a wire mesh over everything. There's radiant heat in the floor, and we had to tie all that together and weld it all together to make sure we had a solid ground plane. And basically all of that's tied to the building steel. We had tried to make like a Faraday cage out of the building.
Wow, interesting.
So we didn't have any background noise. So a lot of people were concerned with, well, what's it going to do to the neighbors and outside? But basically all the testing is contained inside of this Faraday cage.
You guys thought of everything. You guys thought of all that. Excellent.
Yeah. Basically charge each one of those capacitors up to 100,000 volts, and then it discharges it
to
1.2 million volts. And so,
And you see that between the two, that happens. Does that happen over here? Where does that
so
happen?
actually what that's going to do is you could tie this to a test object
Okay.
from this divider point. So this is the point here where
Oh, that was awesome. Okay, Jeremy, you've walked us through the entire facility. You brought us out to this amazing testing center. Everything you guys do here is really great for the town of Newton Falls, the village of Newton Falls. Can you tell me a little bit more about that and just kind of describe a little bit more about how you're helping out the community?
Sure. Well, I mean, we're a small company, but we do employ, we have 40 employees currently, and,
Awesome.
and we're continuing to grow as we expand our product offerings. And our focus has really been on design and engineering, so we're really highly technically top heavy. Like, we have 9 engineers on staff, so out of those 40 employees, we have 9 engineers. And we're really looking to grow, and we have to keep adapting to the market and involved locally with the community. We do sponsor some local sports teams.
That's great.
And things like that to stay involved. We have several family members that live all throughout the community, and so we like to stay involved in the community that way and help Newton Falls grow.
That's great. And I know you do a lot of stuff here in Newton Falls. I know you guys are international as well. You guys are doing a lot of business internationally as well as locally in the area. Tell us where people can find out a little bit more information about the company, and if they wanted to do some more research themselves, where could they go?
Sure. Well, our website's a good resource. QualitySwitch.com has a lot of information about our history and where we're at today, and a lot of our capabilities, and all of our contact info's there, and updates on where we're going to be, trade shows and industry standard meetings and things like that. And basically, going forward, I don't know if anybody's interested. I mean, that's probably the best way to get in touch with anybody.
Okay, so QualitySwitch.com is a good place to find out a little bit more information.
Yeah.
Well, Jeremy, thank you so much. I really appreciate your time today and letting us come in and check out the facility and learn a little bit more about Quality Switch.
No problem.
So, welcome. We want to thank everybody for checking out the first edition of Newton Falls Means Business. Again, my name is Brian Kropp, and we're here for Newton Falls Television. Again, follow us. We're going to be doing this every month. We're going to be introducing ourselves to new businesses locally and getting a little bit more information, just like we did here today with Jeremy Sewell of Quality Switch. So, thanks again, everyone. Have a great day, and Newton Falls Means Business.